Let's do some of the problems on the Trig practice problems sheet. And I think we should do some and set up just some others so we can kind of know how to do them. So here goes. I'm going to start with number 2. I'm going to actually do number 2, the whole thing. So here goes. Number 2, and there's more than one way to do it. There's multiple ways to do it. You know you're dealing with a right triangle, pardon my crooked hypotenuse there. And so we need to label things as correctly as possible. When we read this, we know that angle A is 90, so we know that one is 90. And it doesn't matter where B is, and it doesn't matter where C is, as long as we have the right angle and with the correct letter. So B is 35 degrees, and AC is 14. And then we need to find everything we're missing. There's an obvious place to start. We can find that one first. And I'm actually not going to, but we could. It'd be pretty easy if we did. So we're missing a few things. We're missing angle C, which you can just kind of look at it and tell what that is. We're missing BC, which is the hypotenuse, and we're missing AB. So we're going to find out what all of these are. Again, angle C is pretty obvious. I'm just going to save it to last just because I feel like it, even though you already know the answer is 55. There, I said it. Okay. I'm going to find, it's arbitrarily, you can start almost anywhere on these, and you can just pick one. I'm going to pick that right there. I'm going to call this little guy X. You can call him whatever you want, but I'm going to call it X. And if we're looking for X, we're going to use the angle that we have, and you can use the 55 here if you want to go ahead and pretend like you know it. But what I'm going to do is use this side and this side. That's opposite and that's adjacent. So opposite and adjacent is tangent. So I have the tangent of my angle, and that's equal to 14 over x, and then we'll just solve that. So because the x is in the bottom, we're going to cross multiply. We'll put that over 1 and we'll cross multiply. That gives me 14 equals x times the tangent of 35 degrees. And in order to find x, we'll divide by the tangent of 35. So tan 35 is in the bottom, tan 35, and then we'll grab a calculator. Now, before we even start typing this in the calculator, press mode. Make sure you're in degrees. You've seen this before. But here we go. You press mode. Make sure you're in degrees. I'm in radians, so you need to be careful with that. Sometimes the calculators automatically reset, especially mine. So there we go. We are in degrees. We're going to type 14 divided by the tangent of 35 degrees, and that gives us 19.99. Normally I'm a 2 decimal place kind of guy, but that's just so painfully, dreadfully close to 20 that I just can't resist. So I'm just going to call it 20. So AB is 20. Well, where do we go from here? What do we do? What should I use? Should I use cosine or tan or tan? There's all kinds of stuff you can do. Actually, I'm not going to do any of that. I'm going to use the Pythagorean theorem. Once you know two sides of a right triangle, you can use the Pythagorean theorem. You don't have to use trigonometry. So I'm going to find this one. I'll call it y. Call it whatever you like. So a squared, which will be one leg, plus b squared equals c squared. And so that's my hypotenuse. I'll just type that straight in the calculator. 14 squared is 196. 20 squared is 400. And that's equal to a y squared. So that's 596 equal to y squared. And I'm going to make sure I didn't make a mistake in that. Yeah, right. Okay, so 596 square root of 596 is 24.41. 24.41, there it is, 24.41. And I think we've already discussed what the measure of angle C is. And in case you didn't catch why it was 55, this happens in your head or in your calculator. 180 minus the 90 that we have minus the 35. That gave me 55 degrees here. So that's number 2. And again, I did it this way, but there's multiple ways of doing it. There's all kinds of ways of doing it. You can start by finding the angle. You can sometimes, not on this one, but sometimes you can start with the Pythagorean theorem. Sometimes you can start with trigonometry. You just have to look and see what you have to build towards what you're looking for. Okay, I'm going to set up number 5, but I'm not going to do the whole thing. I'm just going to draw a picture. The hard part about some of these is actually just drawing the picture, making sure your picture's right and everything's labeled correctly. So here's number 5. It says that you're flying your kite, but you tie the string of your kite to a stake in the ground. Well, there's the ground, and there's a little stake, not the steak you eat. That'd be spelled differently. So, and there's 120 feet of string that have been released, and the string makes a 55-degree angle with the ground. So there's a kite flying up here. There we go. there's a 55-degree angle right here. 55 degrees. And I need to know the height of the kite. And the one thing I didn't draw was the fact that we have 120 feet of string. And I'm looking for the height of the kite, so I'm looking for x. I'm going to stop there because I believe you have it. Okay, number 6, however, is tricky. And I'm going to start 6 but not finish it. My eyes are 6 feet from the ground. If you're over 6 feet tall, then that's probably a good estimation. So here's me. Wow, I'm really skinny and have a wavy stomach. My arms are low. Anyway, but I'm 6 feet off the ground, and my angle of elevation from my eyes to the top of a flagpole, so there's a flagpole over here. That looks like a giant hatchet, doesn't it? That does not look like a flag. That looks terrible. There we go. It's a little bit better. Okay, so what I'm going to do is draw my line of sight to the top of the flagpole. Well, here's the deal. I'm 6 feet tall. From here to here, from my eyes to the ground is 6 feet. I'm not 6 feet, but from my eyes down is 6 feet. And here's the catch. I could look straight ahead. So here's the problem with this one. When I find the height of the flagpole, I'm going to have to add 6 to it. That's what I'm looking for, but the whole height of the flagpole is going to be the x plus the 6. Let's fill in a couple other numbers and this will make a little more sense. I'm 76 feet from the flagpole. 76. I'm going to make that a solid line, not a dotted line. There we go. So that's 76, which of course makes that 76. Oh, about the degrees. It's not angle measurement, sorry. The angle of elevation is 54 degrees. That looks like 540. I'm on the struggle bus right now. 54 degrees. And I'm looking for x. So we'll just do the regular trigonometry that we've been doing with this triangle, and then to find the whole height of the flagpole, you'll add 6 to it at the end. There we go. Just wanted to show you that. Number 8. I will set this one up, and I probably will start the work as well. This one's a little bit wordy. You have 2 buildings, and I believe one of them's taller than the other one. You can read the problem. Let's see. Number 8. 2 buildings, one is taller than the other. Yeah, one is taller than the other. They're 100 feet apart, so let's draw it. I like to make my buildings rectangular just because. So there's one of them, and then there's another one. One of them's taller than the other one. I don't know how much, nor does it really matter yet. They're 100 feet apart. I think we're good so far. The angle of elevation from the top of the shorter building, you have to kind of read it slowly and cautiously. Angle of elevation from the top of the short building to the top of the tall building is 30. So I'm going to look up there. Now I could look straight ahead if I wanted to, but the angle of elevation there is 30 degrees. The shorter building is 57 feet tall. 57 feet. How tall is the taller building? I don't know. But here's what I do know. I know that this measurement is 57 feet. It's very similar to the last problem that we did, number 6, the one I set up. So what I need to do is find that and then add 57 to it. I'm actually not going to set this one up. I'm going to stop there, other than the fact that I will say that's obviously 100, that's opposite, that's adjacent, that makes this tangent. Okay. I want to set up number 9. Actually, I don't want to set up number 9. I don't. I'm just going to say one thing on number 9. A lot of times when people do number 9, I've given this problem for several semesters now, they'll say, you didn't give us enough information. Yeah, I did. You prop a meter stick against a wall, making a 13-degree angle with the wall. How far is the top of the meter stick from the ground? And they say, you didn't give us enough measurements. How long is a meter stick? There you go. You have enough measurements now.